My name's Austin Collins. I'm an AWS community hero. I left my superhero costume at home though, and today I stand before you in my civilian disguise, just a JavaScript developer, a DevOps engineer, and the founder of a company called Serverless Inc. When I first started building apps years ago, it was fun until the glamour of building apps faded, the glamour of building anything faded, and I realized what is really going on. And what is really going on, I believe, is an arms race. It's a race to write better software faster. We have to ship features, stability, quality faster. And we're all in the race. Your company's in the race. Your weekend project, whether you realize it or not, is in the race. And it's not a bad thing. It's the way it is. It's the way it probably always has been. But we're spending more money on the tools that help us deliver software faster. Increasing demand for tools, which increases the number of tools. And now there's a whole bunch of freaking tools out there, specifically for cloud computing. And it's tempting to get lost digging into these tools, and they look so fun. And I got lost for a while. But at the end of the day, I had to deliver an application and keep delivering fast, because the arms race is real and it's happening. And over the years, I've transformed into an extreme pragmatist. And tools that introduce complexity, overhead are my enemy, simplicity, my one true love. And to find simplicity, I measure the total cost of ownership. That's what I look for. And this brought me to Lambda, which I believe has the lowest total cost of ownership out of any compute service that there is right now. You simply upload code with a little bit of configuration. You've got pay-per-use pricing, which is a revolution in itself. Manage containers, isolation, already all managed for you, and the thing scales automatically. Again, lowest total cost of ownership. It's I call it the convenient compute service. It's got some quirks, but I love it. And the first thing I wanted to do when Lambda came out was build an entire application on it. And this is what that talk is all about. How do we build applications exclusively on Lambda and API Gateway and take advantage of this wonderful new technology? So, after Lambda came out, I said, this is fantastic. After API Gateway came out, I said, it's the time to start building. And I started to refactor an entire application to run exclusively on Lambda and API Gateway, and I ran into a few problems. Lambda is fantastic, but when you have lots of functions, it means managing lots of containers, and it ends up being like total anarchy. You have just basically a bunch of rowdy containers that need to be corralled somehow. I mean, you can make your first Lambda function, it feels great. Your second Lambda function feels great. But as soon as you hit 10, 20 Lambda functions, there needs to be some structure there, and that was missing. Furthermore, if you add on top of that multi-regions, replicating your Lambdas across regions, staging your Lambdas to have development, beta, production stages, bring on multi-developer teams, all working off the same groups of Lambdas, add in resource management, databases, file storage, REST APIs, code sharing. How do we do code sharing across functions and Lambdas and containers? Local development, how is this done? Testing, security, architectural patterns. How do we architect our code across this fragmented new architecture? And optimization, how do we optimize our Lambda functions for faster response times, because these things need to respond to web requests at the end of the day. And these are the immediate problems I ran into within hours of using Lambda for the first time and refactoring a large application to run exclusively on Lambda. And this is why I made the framework, the serverless framework. I started this project by myself in July 2015. It used to be called JAWS, and it had a cool logo of a shark and stuff. And I put it up on Hacker News, and I immediately walked away because I expected nothing of it, because I thought, like everything else on Hacker News, it would just sink straight to the bottom and no one would ever check it out. But I came back like a couple hours later, and the thing had quickly gotten on the front page of Hacker News. #2 position, hundreds of upvotes, lots of comments, and it was a little weird. All the comments were positive, so something was strange on Hacker News that day. And I realized that this project had struck a nerve, and a lot of developers were responding to it. Specifically the aspects of it that were serverless. All over the branding, I put this is a serverless application framework. You don't have to manage any servers. Not to say that servers don't exist. It's just that the developer doesn't have to think about them. AWS manages them. So that's how this whole thing got started. The day it went viral on Hacker News, I started working on this full time. and it was fantastic. And now, 6 months later, there's a lot of Lambda deployment tools out there. It seems like every day I wake up, there's a new Lambda deployment tool. It's written in Python, it's written in Go. But there's something I learned the second day after this went viral on Hacker News. The first day it was fantastic. It was a huge party. The second day it was the hangover, and all the issues started to come in. And all the issues were, hey, can you add support for this AWS feature? And can you add support for this AWS feature? And can you add support for these 3 AWS features, which then will allow support for this next AWS feature? And I realized that what I was making here was not the serverless framework. It's the AWS application framework that happens to be serverless. And that means that we were building something that had to support all of AWS's vast functionality and give it order and structure in some simple way, and that was a huge challenge. So it's been 6 months since I've been working on this. We now have raised some money to do this full time. We got a team of 3 full-time people so far, and we've come a long way. But the point is, we're here to make an incredible application framework that covers AWS's vast functionality, abstracts it, simplifies it, and also runs everything on Lambda. Everyone on our team, we think that Lambda is going to be the focal point of AWS Cloud. And what that means is in the future, we may all be using Lambda as the compute service for doing anything on AWS. And we've designed this framework so that it interprets AWS from the perspective of Lambda. So let's dig into it. I'm going to do a quick demo here. Here's the GitHub repo. Again, this is only 6 months old, but we've skyrocketed to about 7,000 GitHub stars. We have lots of enterprise companies already digging in, talking to me about how they could put this into production, which I think is amazing given how early this is. There's our sweet README logo. Anyway, this is all a Node.js application. It takes the form of a command line interface. And to install it, you just run npm install serverless. Throw in the global flag here. Anyway, Node.js application, you install it via npm. It's installed, and now you have serverless commands. So I could type in serverless here, and it's going to give me a list of all the things that serverless can do, which is quite a lot. You can call the CLI tool by using serverless. We also have a shorter version, which is just SLS. And let's create our first project here. All I have to do is type in SLS project create. We're going to get some instructions here, initializing our first serverless project. Enter a name for this project. Let's call it Demo 1. Enter a universally unique project bucket name. So this right now is going to create some scaffolding on our computer. It's going to create a file structure for a serverless application. In addition to that, it's also going to create a S3 bucket on your AWS account. And in this S3 bucket, it's going to store backups of your Lambda functions. It's going to store backups of your CloudFormation templates, because this is the first framework that not only manages your code, but your infrastructure all in the same project. And it's also going to store on that project bucket, it's going to store environment variables, because Lambda doesn't have environment variable support yet. So we've had to sort of fake it until they make it. An email for AWS alarms, that may or may not be relevant to you. And then it's going to ask you to select the first region for your project. This is a multi-region framework. You could have multiple regions in your project, and I'll get into that in a bit, but let's go with East 1. If you have an AWS profile already on your computer, it'll detect that, and it'll prompt you to select which one you want to use. These are your credentials to the AWS account that serverless is going to access and create stuff for you. If you don't have a profile, it's going to prompt you and say, hey, you don't have any profiles, enter in some access keys. And you can go on AWS, create an IAM user, and create and get the access keys for that and plug it in right here. So I selected my default profile. Serverless has my credentials to my AWS account, and now it's going to do some awesome automation. The first is it's going to create a stage for me. So this application framework has the concept of stages built in. Stages, same thing as environments. And it's automatically going to create a development stage. And in your project, you could have one or infinite stages, and each stage can have one or multiple regions. So it's going to create a dev stage and then a US East stage. And then it goes and creates a project bucket on S3, which is going to store backups of all my project information. And then it's going to do something else that's really interesting. Again, this is the application framework that manages your code and your infrastructure. And in each stage, in each region, it's going to create a replication of your infrastructure via CloudFormation. And it's going to deploy that stuff, or you can deploy it whenever you want, to that stage and to that region. So already with a simple command, we have our first development stage. We're using our first region. We're creating a project bucket to store backups for our project, and we're deploying our resources. And the first resources that Serverless is going to create for you is just a simple IAM role that your Lambda functions will all share and use. While that's running, it usually takes 2 or 3 minutes. I just want to show off the internal architecture. Again, this is the AWS application framework that happens to be serverless. And we've spent hundreds of hours trying to make sure that this architecture here is clean and scalable so that we can grow elegantly to support all the functionality that AWS offers. And we've ripped out the core internals and rewritten them maybe like, I don't know, 20 times or something. And the result is pretty straightforward and accessible. So if you're interested in contributing to open source, this might be a good project for you if you're already savvy with JavaScript. Basically, we have a lib folder here. And everything that the framework does is divided into actions. So every cool automation that this thing does is in its own action, clearly isolated. So here's function deploy right here. You can create a function, function logging. If you want to run a function locally, everything is in its own file. Furthermore, whenever the framework is first loaded, whenever you write that command in the CLI, your whole project is loaded into memory. And any of the actions can work with those project assets just by using our simple classes. We have a class for all of our project assets here, and each class has a ton of useful methods. So you could easily write some type of extension for this thing that allows you to work with assets and do sort of anything you'd like. Anyway, let's get back to it here. So our CloudFormation is finished. We've created our initial resources. You can see there's a few success messages here. We successfully deployed our development resources to US East 1. We created that region, we created that stage, and the project is ready to go. And open it up. And let's take a look at what a project file looks like. All right, this is the scaffolding that Serverless has just created. We don't have much going on here. We have a .env file, .getignore file, pretty straightforward. There's a README that's automatically created for you. Of interest is the sproject.json, which saves our core project configuration right here, the name, the version, author, description. Also of interest is a meta folder. So as I said, the serverless framework has a concept of stages built into it, and we store all that stage data in your meta folder right here. And even better, we have another concept called variables, because in your configuration files, it's really hard to have a whole bunch of configuration for project assets that are working across all your stages. And the way we make that work is you're able to specify certain variables for each stage. For example, here are some variables that are automatically created. And you could take these variables and put them right in your project configuration files so that when you create project assets, these will work across all your stages in your project, which is very cool for teams who are collaborating on this. Everybody's using the same Lambda functions. They're using the same CloudFormation templates, and you could put variables in there that change depending on the stage that those team members are working on. Also, there's a resources folder here. Every resource file here is a CloudFormation template. The stage that this CloudFormation template is for and the region that is for has been saved here. And this is what Serverless creates out of the box. It's just a straightforward IAM role with a simple policy that allows your Lambda to do basic tasks. If you want to edit your core project resources, there's an S resources file right here. Again, it's another CloudFormation template. The difference is, in this one, you could use your stage variables in here. And basically, whenever you add something to this CloudFormation template, there's a command called Serverless Resources Deploy, which will deploy it. It'll save a copy of the CloudFormation file right to your resources folder here. It'll push it up to your project bucket, and then it'll go deploy it on CloudFormation for you. Now, this is a fully interactive CLI, and it does lots of cool stuff out of the box. So I just CD'd into the project file. The first thing I'll do is let's just check out the project. We have these dashboard commands. And the first I'll show you is dash summary. This shows a simple summary of your project. We have one stage, it's the development stage, and it has one region. There's no components, we'll get into that next, and then there's a quick summary here at the end. So at any time, whenever you're working on your project, you could just call this command and see what's going on. We have one other piece of scaffolding here that you should be aware of. In our project file, all the Lambda functions are kept in root folders in your project folder. And these are called components. And components define a runtime. Not only is this the first application framework that controls your code and your infrastructure, but we actually have support for multiple programming languages. And we're working to support all of the languages that Lambda supports. And to organize all your functions cleanly by the programming language or by the runtime that they use, we have this concept of components, which is just a folder in your project that says, hey, all the Lambda functions in this folder are Python, or all the Lambda functions in this folder are Node. So let's create a component real quick. And we're going to create a REST API component because we're here to make a web application, a backend for a web application. And this is going to add some simple scaffolding to the project. Here's our REST API component. Again, it's just a folder in your project. In here, there's a little bit more automation that's done for you. There's a package.json for dependencies that you want, if you want to share stuff, share code across all your Lambda functions in this component. This is how you do it. There's also a lib folder if you want to write some custom code that you want to share across all the functions in your component. All this stuff is created for you, as well as an scomponent.json file. And you can see, pretty simple. Here's the name, here's the runtime, and custom is something else that we'll get into later. So the component is created. I could check it out right here. It's in the dashboard. Now we have, our stage, our first region in that stage, and our first component. Now let's create our first function. All right, so we have a simple function create command, and in it you just have to specify the component. If you want to nest your functions in subfolders, you could do that. A lot of people like that. In the beginning, it used to just be a whole bunch of functions in the same folder, and once people hit 70 Lambda functions in their project, they said, this sucks. It's just too cluttered. Can we nest these things in subfolders? And we said, sure, that makes sense. So by using the simple command and specifying a path, serverless will create a function and nest it in the subfolder that you specify. So that's it. The function was created. If I look at the dash summary again, we now have one component, our REST API. It should say we have one function and one endpoint right there, but the labels are a little off. All right, so here's our project scaffolding again. Now we have a users folder in our component. And in the users folder, there's a show folder. And in here is our function. This is JavaScript. This is Node.js code for our function, as well as an event. If you want to run the function locally, you could do that. And if you want to populate it with any data, you just put it in this event object. There's also an sfunction.json file, which specifies your Lambda function configuration. And if you're familiar with Lambda, this stuff will be familiar to you. The only thing that we add on extra is that you could easily add endpoints to your Lambda function right here. And out of the box, we create your first endpoint for you. We give it a path and a get. You can add multiple endpoints to your Lambda function. And furthermore, if you want your Lambda function to be triggered by events, you could specify them right in here as well. So our function was created. If you want to run it locally, we'll just use serverless function run. We'll call it, and we just call the function. And that's what the function is designed to say. It just says, hey, your serverless function was run successfully. Pretty straightforward. Next up, we have a separate dashboard for whenever we want to deploy our project assets. It gives another summary of all the assets in your project. Again, here in the REST API users subfolder show function, we have a function and an endpoint. The command line tool picks this stuff up automatically, and you could toggle through the assets of your project that you want to deploy and hit deploy. So whether you have a couple Lambda functions or 70 Lambda functions with hundreds of different endpoints, you could toggle through them and deploy each thing individually. There's also lots of flags here, like you could do serverless function deploy -all. It'll deploy all the functions for you. Same with the endpoints. And you'll see that the functions are deployed first. And what you get here, they're deployed to our dev stage and in the US East region. And what you get is the ARN for those functions that you deployed. Second off, after the functions are deployed, serverless then goes and creates all the endpoints that you specified in your project and attaches those to your function and spits out a URL. And if we enter in that URL into our browser here, it runs. And this is fantastic. You basically have this managed container that's infinitely scalable that only charges you whenever it's called that you've deployed within a few seconds. And as you keep working on this, you keep modifying your functions, just go back and redeploy them. Again, every single time you deploy Lambda functions, what serverless does is it uploads a copy of the function to your project bucket, so you have a backup there. Soon we're going to bring on rollback support, so you could either roll back to, so that you could roll back to the Lambda functions in your project bucket. And then serverless takes the Lambda function, deploys it on AWS for you, automatically versions it. So every single time you deploy a Lambda function, the version gets bumped up. And then it adds an alias to that version with the stage that you deployed to. So we try very hard here to isolate everything by stages and regions. And the result is, I think, unprecedented agility, especially when you look at just the ability that you have to work with your applications projects independently from one another. When I first started this project, I thought, oh man, this pricing model rocks. I don't have to waste a whole bunch of money every single month paying for server resources anymore. I don't know about you all, but I've got a building problem, and I just build stuff like crazy, and I'll deploy it, and it just runs, and it charges me every single month. And at some point, I looked at my bills, and I'm like, I'm paying like $800 a month for side projects. And anyway, so so I thought that the pricing model was going to speak to a lot of people. It certainly spoke to me. But as I continued this project, what I learned that more people were interested in is that this offers unprecedented agility. Containers, orchestration, servers, it's all handled for you. And now you have this complete freedom to isolate and divide your logic however you'd like. And work with components in your application independently of each other. So at any time, I can go to this endpoint, change the configuration for this specific endpoint, change the Lambda function that's right behind this endpoint as well, and it's not going to affect any other endpoints in my REST API. A lot of people have custom build steps that they need to perform. Lots of companies, it's a very subjective thing. And I recognized this early on, and this is why we've spent so much darn time refactoring the core architecture to have a clean actions layout, because what this enables is anyone could write a plugin for serverless that replaces one of the core actions in the platform with their own custom logic. It just targets one action or multiple actions, or it adds hooks, that logic that could fire before or after an action fires. And the plugin community has sort of taken off. I think this is only like half the plugins that have been written so far, but many of these things add custom build steps that fire before any of our actions fire. So some of the best ones here, I mean, they're all pretty cool, but this optimizer, this is the only one that we made. And the optimizer is specifically for Node.js. What it does is it browserfies before it deploys your Lambda function. Whenever you do serverless function deploy or serverless dash deploy, the optimizer browserfies your JavaScript code. So it only extracts the stuff that that Lambda function is using, and then it minifies it, and that's what it zips up. And the result is you have this really tiny file size for your Lambda function, which is fantastic because you could upload it much more quickly. Furthermore, we believe it helps the performance for when your Lambda actually runs. There's a lot of stuff that Lambda does behind the scenes, but one thing we know is that whenever a Lambda is firing up from a cold start, AWS has to download it from S3 and unzip it, and the smaller the file size, we believe, helps that. I haven't dealt with a lot of that specifically, but one thing I feel strongly about when I started this project is we don't want to really abstract too much. All we really want to do with this project is just put some structure around the raw AWS SDK. And when you look at our configuration files here, the configurations properties, these are all the raw properties, the raw parameters that the AWS SDK takes in. So theoretically, anything that you could do on the AWS dashboard or anything, they're all using the SDK as well. It's all available right here. And we added a little bit of magic here because normally you'd have to stringify the request template, which is just a lame user experience. And a contributor came in and he said, like, oh no, we'll just stringify it later, and you could just write it out as a normal JSON object. So yeah, that's possible, and we've tried to improve it there. We have, as I said, there's endpoints is an array. Put in 1 or 100 endpoints right in there, and I'll dig in on some cool patterns. In just a few minutes here, what I see people doing, that seems kind of groundbreaking to me. All right, I'm going to get into some cool things that we're seeing now with the framework that I think is just head and shoulders above everything else that's out there. As I said, you could have one or multiple components in your serverless project. This one just has a REST API component. For a while, we only supported Lambdas that were triggered by API Gateway. We finally brought in really nice event support for S3 events, CloudWatch, DynamoDB streams. So we have that now, and this is what I think the ideal application looks like. I think that in your serverless project, you should have a few components. One for your REST API, for your back-end code, but also another component that just handles events on your AWS account. This is a really nice way to add in all this functionality into a simple project file, because there's a lot of events that you want to be able to handle, like image resizing if an image is uploaded to an S3 bucket or something. That code shouldn't actually be in your REST API. This could be handled separately. And so this is a really nice way to separate these two things. And furthermore, I see this huge demand for utility functions for people's applications, Lambdas that comb through logs, or Lambdas that do security audits, all that stuff. I think that this is the first time, and Lambda is the right compute service that enables you to build a project and have all that logic in one place, and this is the way to organize it. I think that's, I just don't think there's anything else out there that's like this. Second, I want to talk about code architectures for a second here. In the beginning, we saw more of a nanoservices pattern with Lambda, and that was that people would make a Lambda function for each individual API endpoint. And that's really cool. It makes monitoring, debugging those Lambda functions really easy. This Lambda function does this thing. And it's also really agile. Again, the level of agility here is phenomenal. And this way, with this pattern, you can manipulate, update, work on each API endpoint completely independent from the rest of your application, and that's powerful. But there's a lot of people who do what we call the Microservices Pattern. And these names, I don't know, they're a little fuzzy, but I think of this as people will make a Lambda function that handles a resource, for example, their users' data. And that single Lambda function will have multiple endpoints for CRUD operations on that resource. And in the Lambda function, you could say, oh, what was the path that API gateway used when it triggered this Lambda function, and what was the method? And you could actually use the Lambda to route to the correct logic, from whatever the incoming response was. So these two are really interesting. This one, there's still a lot of agility here. I see people using this more and more because they just don't want to deal with more Lambda functions. And then there's something else that's really caught our interest lately. I'm just calling this the new monolithic architecture now. I don't know if anyone here has heard of GraphQL. Is anyone familiar with GraphQL? Okay, there's a couple people here. This stuff blew my mind. I had a contributor come to me and he said, "Are you looking at GraphQL? It's a open source project that Facebook is putting out." And I said, no. He said, it's amazing, and we got to put it in a Lambda function because it's going to be an awesome set of tools. And so GraphQL, I'm still a little bit new to it personally. But this is a runtime and a query language that Facebook has made, and they have various implementations of it in different programming languages. So they just open sourced this a few months ago, I believe, and there's a Node.js implementation of GraphQL. And what you do with this is you could put it in front of your persistence layer, multiple database options. For example, you could take GraphQL and put it in front of like 5 DynamoDB tables. And then you could hit GraphQL with an incoming request and request a shape of data. And that shape of data can include attributes from data objects across data sources, like across DynamoDB tables. You say, hey, I want like 10 users, and I want, maybe for like an e-commerce thing, I want like 3, I want the title of their latest orders, and then I want the first 3 reviews for each of those products that they ordered, all merged into one object. And GraphQL will query all your data sources, concurrently aggregate that the resulting data objects and merge it into the shape that you requested and spit that back out. Now, why is this cool? Because this means you can have a REST API endpoint, a REST API that only has one endpoint. And Facebook claims that they're using this. I don't know about these claims, but they say they're using GraphQL to serve all of their mobile applications and via like a single REST API endpoint. And they're serving over 1,000 versions of their applications with this single REST API. And as those applications iterate, as the versions change, and they need new types of data, they just change the shape of their incoming request. And they send that up to GraphQL, and GraphQL can handle it. And it's very interesting from the perspective of if you ever had to deal with storing historical records of data and stuff, this reduces that significantly. So we thought, like, wow, single endpoint REST APIs, how do we, putting that in Lambda, there's like nothing cooler than that. And we made a proof of concept recently, and we worked with the contributor to do this. It's called the Serverless GraphQL blog. And this was a cool project. This also made the front page of Hacker News. But it's a serverless blog, and it uses 3 DynamoDB tables. It has one for authors, one for posts, one for comments. And it has, if you go into it, it has one Lambda function. And in that Lambda function, it has one endpoint. And here's the path. The method is post, and you go in there and you say, hey, I want the first 10 posts, and I want like the name of the author in there, and I want the first 3 comments, or the name of the poster of the first 3 comments. And that's how you shape your request. You could shape it however you'd like. You ping the single REST API endpoint, and GraphQL is sitting in the Lambda function. Your request hits that first. It queries these 3 DynamoDB tables concurrently, pulls in the resulting data, combines it, matches it to the shape of your request, and spits it out. So for us, the idea of having serverless, the idea of having REST APIs in Lambda is already phenomenal. It's managed for you. It instantly scales. You only get charged per use. And if you could use GraphQL to reduce the number of endpoints for your REST API down to like 1 or 2, you may have another one that handles your admin API. I think that it doesn't get much more efficient than that. Lambda also doesn't have support for JavaScript ES6. Fortunately, we wrote our optimizer plugin so that it runs your code through Babel, so allowing you to use ES6 syntax in Lambda, and that's what you're looking at here. But it hits that. I guess all the schemas here are stored in this schema file. We only have about 116 lines of code here. And here's our DynamoDB logic. You basically have to train GraphQL how to pull in your data from these data sources, and it doesn't have to be a single data source. You could have DynamoDB and Redis, and then some relational database system, and put GraphQL in front of all of those. But I think Kevin, he was able to pull this off in under 300 lines of code. At the end of the day, what I see people doing is they mix these code architectures. Some endpoints, they'll have a Lambda function for each. Some of them, they'll try and hook up multiple endpoints to a single Lambda function. And this is still so new. We only created that proof of concept a few weeks ago. So who knows where this will go, but we're pretty bullish on it. We're trying to use it wherever we can because it makes maintenance so much easier. So lastly, we have a great community. There's a couple people from our community here today. I think we're up to about got about 616 people. I'm in here all day long. Our team is in here all day long, and we're trying to handle your requests. At the end of the day, this still is the AWS application framework, and there's a lot of requests that come in. So we can't get to them all. Also, you saw that we have plugins. I think that there's a lot of great plugins here already. Someone wrote, I think this is the most popular one, is the Serve plugin, which adds a server to the serverless framework, which to me is kind of hilarious, and especially because it's the most popular one. It basically just creates a local server, so you can run your Lambda functions locally, just like any other local server, and do better local development. Lastly, we made project files shareable, so that people can start sharing their serverless projects. And they're basically, we use NPM as a delivery mechanism, and you can run serverless project install to install a project that's already been created, and you'll see that the GraphQL blog is in here, and instantly deploy that. Next up for us, we're going to come out with version 0.5, which adds in lots more features and support for plugin development. And after that, what we need now is a serverless application boilerplate project. I think finally all the pieces are in place to make a great boilerplate project that includes plugins in it, as well as we like to offer a user's CRUD example, as well as authentication. API Gateway now has this new authenticators feature, which solves the authentication problem for a lot of people. And we're going to release that in probably a week or so, and you'll be able to install it with Serverless Project Install. And you should be able to get up and running within a few minutes.